Neil deGrasse Tyson fervently explains that the most upsetting and frustrating discovery made by Voyager in the last 10 years is that the probe returned troubling information from space that left experts uneasy, and everyone in a tense mood. Scientists and analysts have been taking time off from their regular tasks to investigate these mysterious objects that Voyager just detected. We don't know where these strange things come from or where they're headed, but we can be sure that we've never seen anything like them before. What are these perplexing items discovered by Pioneer 1? Come investigate these responses in Neil deGrasse Tyson's Pioneer 1, which has been detecting 500 dark objects in space for over 50 years. Voyager 1 has been exploring regions of space inaccessible to Earth-based observatories and making incredible discoveries that have left us in awe. Neil deGrasse Tyson recently confirmed that Pioneer had discovered 500 dark objects floating silently in space. This news shocked many scientists and sent them into a frenzy as they began analyzing the data collected by Pioneer 1. Experts struggled to understand the surprising finding, and various theories began to circulate as scientists tried to piece together the mystery. If another rocket had sent back this puzzling data, researchers might have questioned its accuracy, but we are talking about Pioneer 1, a space probe that has been exploring the vastness of space for almost 50 years and has surpassed our expectations. Much like a patient who has recovered from an illness, Voyager 1 has surpassed the scientists' initial expectation of a 3-year mission, spending over 45 years in space and making groundbreaking discoveries. The most fascinating aspect of the story is that Pioneer is sharing the incredible journey from billions of miles away. The last time researchers checked, Voyager was 14.5 billion miles from Earth, continuing its journey through space without any sign of slowing down. Researchers report that the space probe travels at a speed that covers the distance between the Earth and the Sun many times each year. This fact has been hard for scientists to accept, considering that one would expect the probe speed to have significantly decreased after so many years. However, it seems that Voyager 1 is an exception, and its recent discoveries support this. Had seemed like an ordinary day for scientists when Voyager 1 sent exciting news that would be remembered for a long time. The probe accidentally discovered some unusual objects passing through space. This revelation was shocking, explaining the initial confusion among cosmologists when they found data showing around 500 dark objects appearing from nowhere. In an instant, we went from having no information about these objects to experts scrambling to find answers to this puzzle presented by nature. Scientists were in a dilemma, and the blame could only be placed on one party, Pioneer 1. Suddenly, researchers knew that finding the answers lay heavily on the shoulders of the space probe. At first, when news of this discovery broke, some scientists speculated that it could be a mistake. They thought Voyager might have mistakenly detected these objects and sent back incorrect data. If we follow this line of thought, it seems like a plausible explanation, especially since Voyager 1 was launched back in 1977. Almost 50 years of active service for humanity might lead one to expect that the probe's computers would have worn out and begun to malfunction, sending back low-quality information to the ground team. As interesting as this theory is, scientists have cautioned against jumping to conclusions, as it would undermine the probe's achievements. Despite the harsh and unpredictable environment of space, Voyager 1 has consistently sent back valuable data about our universe to find the skeptics. The probe's two redundant computer systems, like as its twin Voyager 2, are what have allowed it to endure so long. 2 sets of command data processing and control systems were installed aboard Voyager 1. This redundancy has been the key to the probe's continued success in space exploration and discovery. When developing Voyager 1, this inherent redundancy made it possible to swap between systems continuously and to activate and utilize computer components to extend their lives. Earthly engineers created plans to optimize the space GRPH performance, which required that the instruments aboard the probes be constructed with reduced systems to accommodate power and time restrictions. In order to combine power management with 6 onboard computers arranged as a dispersed system with 3 dual redundant pairs, electrical engineers determined that the instruments should employ simple systems based on hardware logic. After overcoming this obstacle, scientists had to deal with the next major problem, which was to keep the systems operating. They did this by developing a power management strategy. This is where it gets interesting. Power management was necessary to maintain the Voyager computer systems operational components given the spacecraft's limited power supplies. This was a difficult undertaking, but specialists came up with a plan to monitor and optimize power utilization. The plan shutdown of non-essential systems is one actual example of these energy management techniques in order to identify and disable parts or subsystems that weren't essential for the probe's main mission goals. Researchers had to make a tough decision. This can be seen when looking at the radiators connected to some instruments that had to be turned off, originally designed to keep the instruments at a certain temperature. For best performance, the strategy was changed to only turn them on when required to drastically reduce the spacecraft's energy consumption. This has a positive knock-on effect that extends the probe's operational life. It is important to emphasize that the choice to turn off non-essential systems wasn't taken hastily. Rather, it necessitates a rigorous evaluation of the trade-offs between energy conservation and achieving the spacecraft's scientific objectives. Every choice necessitates teamwork in assessing how shutting down certain systems will affect the caliber and accessibility of scientific data. Putting feelings aside, the team focused only on the facts at hand, trying to maximize energy efficiency while making sure the spacecraft could keep gathering crucial data about our universe. Scientists and engineers insisted that nothing should prevent Voyager 1 from discovering the profound secrets that the universe has long kept hidden in the far reaches of space. Furthermore, power reduction isn't the only tactic NASA specialists are using to keep Voyager operating in space. They also had another important advantage to support the probe. The team developed energy management plans that adjusted to the constantly changing conditions of the probe's environment. For example, as Voyager moves farther away from the sun, the amount of solar energy available decreases. This presents a challenge, but the experts were ready and made sure the spacecraft adjusted its energy consumption accordingly. This flexible approach benefits NASA scientists and engineers because it ensures that the available energy resources are efficiently distributed to support the probe's critical functions and data transmission back to Earth. The good news doesn't stop there. Engineers have been able to improve the spacecraft's power system over time thanks to continuous technological advancements and improvements in energy management. Upon closer inspection, these improvements include more effective energy distribution. Voyager 1 and its brother, Voyager 2, are now able to continue their exploration of the cosmos because to better battery charging methods, developments in energy regulation, and careful planning and management of energy supplies. The scientific community was shaken by the statement Neil deGrasse Tyson's revelation, which was widely shared, highlighted how Voyager 1 had conducted a thorough inquiry for 10 years in the expanse of interstellar Space before discovering an unanticipated operation. 500 enigmatic items, their origins and functions hidden in extreme secrecy, softly traversing the empty space. Researchers and scientists from all around the globe started working together to comprehend these odd things in an effort to determine their origins and functions. After this shocking discovery sparked a surge of scientific interest. The important discovery made by Voyager 1 ushered in a new era of space research, appending pre-exist hypotheses and generating novel concepts on cosmic mysteries. As we continue to unravel the riddle, the further examination of this data promises to deepen our comprehension and maybe provide fresh perspectives on the nature of the cosmos and our position in it. The ultimate objective is still to discover the truth about these dark objects and how they affect our understanding of space. As scientists continue to examine the 500 dark objects that Voyager 1 discovered, the scope of the investigation has grown, and the probe's initial data has already generated a number of intriguing theories. According to one theory, these objects may be materials that are unknown to modern science and might indicate new types of matter or completely new physical processes, or they might be remains of past astronomical events like debris from exploding stars or splintered asteroids. Particle physicists use sophisticated computer models to study the motions and speeds of these items in order to duplicate their paths and potential origins. Researchers want to know whether they came from a single source or if they were the result of many different occurrences. This part of the research is essential to comprehending the discovery's wider ramifications, such as the possible presence of hitherto unknown cosmic cycles or interactions. Global observatories have teamed together to monitor these objects. Ground-based telescopes are being used to confirm why and supplement the data that Voyager 1 returned, offering a more thorough understanding of their characteristics. High resolution along with observational efforts. The main goals of this investigation are imaging and spectrum analysis to find any chemical signals or physical traits that might provide more insight into their existence. Theoretical physicists are investigating how these discoveries might impact our knowledge of basic physics. If the objects display peculiar gravitational or electromagnetic characteristics, they may provide new information about theories of dark matter or dark energy, which could change how we perceive the most enigmatic features of the cosmos. Additionally, the finding has spurred cooperation in a number of fields. Experts in material science, mathematics, and cosmology are all lending their expertise to help unravel the mystery. These unknown items provide. This collaboration guarantees that all possible perspectives are considered and promotes a more thorough comprehension of the facts. This new astronomical riddle is now being included into the curricula of research facilities and educational institutions in an effort to motivate the next generation of scientists. The public's interest in space exploration has increased, and many people are eagerly following the investigation's progress. This renewed enthusiasm for space science has resulted in increased funding and support for space missions and research, reflecting the discovery's widespread appeal and significance. However, the implications of the discovery go beyond science. If these objects are found to possess unique properties or behaviors, they could lead to practical applications in industry and technology. For example, if the objects contain new materials with exceptional strength or conductivity, they might be used in advanced manufacturing or electronics. As the investigation continues, the academic community remains cautious but hopeful. Voyager 1's data is being carefully examined to rule out any mistakes or irregularities to evaluate the results, and guarantee that the conclusions reached are solid and trustworthy. Peer review and replication studies are crucial. Voyager 1's discovery of 500 dark objects has paved the way for further space research, and the current study of these enigmatic objects is set to advance our understanding of the cosmos, test accepted hypotheses, and maybe unearth groundbreaking disk discoveries as we await further revelations. The coordinated efforts of scientists from all across the globe underscore the significance of this discovery and the never-ending pursuit of knowledge that propels space travel. The enthusiasm and expectation around this enormous enigma are only growing, offering fresh perspectives on the darkest mysteries of the world.